In this video, I'd like to address some recent events that have transpired in the world of cybersecurity. And I hear there's been a pretty large outage.
Good morning. Good to see you. You are coming on the air right now with breaking news. A massive global technical outage.
Crippling IT outage. The largest IT outage in history.
Which has affected some significant sectors of our economy.
IT outage ever.
It's impacted different businesses and different sectors of the economy in wildly different ways. And the reality is we're going to be seeing the tailpipe of this for weeks to come.
This is obviously a large problem, and I want to talk about how I think blockchain can help solve some of these issues which we've been running into here. Really what this comes down to is an operating system level update being issued by a kind of cybersecurity provider, CrowdStrike in this case, and it's caused a whole bunch of computers to blue screen of death and crash. If you go to your computer and it crashes, then obviously you're up a creek without a paddle and you're not in a good spot. So how do we stop this kind of thing from happening in the future? There are a few different things that we can do to prevent this type of attack. A few of them involve blockchain, and that's my area of specialization. So I thought I would cover a few of those here in a little bit of detail. Firstly, when it comes to the business logic, the actual kind of nuts and bolts of people getting together to agree about how systems should operate, there are things called protocols. And protocols are understandings between machines and sometimes even understandings between humans about how a system should operate. Whether it's an airline trying to, route all of their flights and decide about, what planes should be going to what places, or whether it's a financial company trying to decide what trades should be executed on a stock exchange. These things use different protocols and systems to interact. And right now, these protocols are generally executed by a single machine that serves to facilitate all of the operations we're trying to do. And that single machine, if it ever crashes or gets rebooted or has a blue screen of death, as we see with these current, these current issues we have with this outage, obviously it acts as a single point of failure. And if your stock trading engine isn't able to execute transactions on the stock exchange between parties, or if your routing software for your flights is not able to execute properly, then you've got a single point of failure. And sometimes this can happen even at the operating system level, where a computer is simply not able to boot up and therefore not able to do its job. By contrast, if we were to take these protocols and rules, the actual requirements, from a business level, the business requirements of these systems, and define them within the context of smart contracts, which are little agreements we can put or bounties for execution of particular tasks within a blockchain, then we have a distributed system that starts to emerge. Because we have the systems that kind of propose these bounties, and there's many of those, right? Maybe there is the requirement of getting all these different people from one airport to another, and so that airport could kind of broadcast, well, I have these passengers here right now, and here's where they need to end up. And so they could kind of broadcast these requirements out in this sort of bounty system. And then because the blockchain kind of can act as a distributed registry of all of these kind of requirements as they're defined within the transactions on the blockchain that kind of set up these bounties, we can have a distributed network that starts to emerge. What this network can enable is different people who try to meet these requirements by defining the kind of operations that need to be performed, whether it's routing planes across the sky or trying to execute financial transactions within a market. You can actually create a distributed network of solution providers who are competing in this manner. And so this distributed network is more resilient because suppose you have, say, 5 different competing, logistics providers trying to figure out how to, save the most fuel and get the most passengers from point A to point B with the available resources from different airports. And suppose 3 of them are running Windows for the people at that company, right? Well, then those 3 companies would unfortunately be taken offline by this recent outage at CrowdStrike, right, where they pushed this update inadvertently. But suppose 2 of those 5 companies were actually running Mac OS or Linux for their workforce, probably Mac OS. Well, I'm happen to be recording this video on a Mac right now, and my Mac wasn't affected by this vulnerability. So if there was many different companies competing to kind of offer these services in a distributed marketplace, and if that protocol and all the rules about how the system is to be operated were registered on a distributed and competitive kind of registry for all of these types of logistics problems in our example here, then some companies would continue to operate, and some teams of people would continue to be able to provide the services to these airlines or these other companies. So this is called overlay networks on top of a blockchain. In fact, the BSV blockchain is probably the best blockchain to enable overlay services to work. And these overlay services can kind of act as these registries, tracking the business rules and requirements that facilitate the operation of large enterprises. And so the solutions to these problems can be sent back by these 2 remaining logistics companies who are not affected by the outage. And because they follow those same rules and kind of fit into the patterns that are required by the people who made these kind of requirements and who sent them out to begin with, those rules could continue to be followed by those 2 remaining companies, and the operations would continue because we've used a distributed system with multiple different providers, and we've eliminated the kind of single point of failure that is that central server that fills this role of trying to execute all of these things in one piece of software. So when there's one piece of software for logistics and it only runs on Windows and there's only one company contracted to do this, then you're going to have problems. But when you have 5 different companies and 2 of them use Mac OS and 3 of them use Windows, then you can have multiple different pieces of logistics software, multiple different teams of people who sit in those rooms and have access to this information and can facilitate these services. And that way, a few of them might go down every once in a while, but the system is resilient. And that's what blockchain technology enables, is the registration and tracking of the fulfillment of business requirements such as these in a way that facilitates this resiliency. And it also reduces cost by introducing kind of market level competition at the level of specific problems in logistics or finance or whatever, matching the pairs of financial assets as they're being traded, that kind of thing. So the first thing I wanted to talk about here is overlay services as a solution to these types of problems. The other thing I want to talk about is the applications themselves. So applications right now always rely, or almost always rely, on a centralized server that kind of gets all of the information out to people. So if you're doing something like a news broadcast, you have a single server, or you have a single broadcast point where your television studio is in a central location, and you have infrastructure that all kind of points back to it. And then from that central point, it's sent out to different people. And so if you try to route all of your broadcasts through a particular single point, then you have the ability to control the video feeds at that single point and what have you. But there are disadvantages to this. If your servers and your computers that are in that particular studio are unable to operate for any reason, then you run into issues. So imagine if there was a division of labor here, right, where you have particular news anchors who are broadcasting live from particular places, and they all put a video feed up to maybe a pool feed or something like that. Well, then those pool feeds could be registered, on a blockchain, and you could purchase access to kind of decrypt and view live those pool feeds, and maybe access the licensing necessary to use that in live news reporting or what have you, right? Different teams of reporters on the ground in different locations, and they get paid because they get the footage and they get it up onto a distributed network, and then anybody who pays for it from that point can access it. Then you have, instead of having a single studio that facilitates things, you have kind of a network where there's obviously different people who choose which feeds are important for particular channels and what have you. But there could be multiple of those, so that you have different aggregators of particular content providing, say, commentary, subtitles, different services to a network, and all of those can be combined and aggregated at different layers. But at each layer there is distribution and resiliency. This type of distribution can happen because we architect applications in a way that facilitates specialization. So one layer is just to get the footage up to a distributed network, and another layer is which aggregators are available to pull different feeds together and add these different services, such as commentary, subtitles, the little title bars on the bottom of the screen, all of that kind of thing. And there's specialists who just do that, right? And if one of those companies goes offline, well, you have other ones who can incorporate the same footage. And at that level, you have a resilient network for news broadcast and availability of information. So once again, instead of having a single central server and a single central company that's fully vertically integrated, you have distribution, and then you also have division of labor, where different people specialize a little more than they do now. By architecting applications in this way and making it so that someone's job is to sift through a whole bunch of live feeds and add captions to it, and that's what they do. That's what their specialty is, right? And someone else is competing with them, and whoever when a big news network chooses to pull in that feed versus the one that they were pulling in before, those people get paid, right? Because they're downstream, right? The people on the ground reporting live, they get paid. But you can architect the network in a distributed way, and this kind of thing is more resilient to the kind of outages and failures we saw today with this exploit or this crash. Obviously, our computers, a lot of them run Windows, and this is a Windows-specific vulnerability, and macOS wasn't affected. So we kind of see a degree of distribution and specialization there. But one company can outsource a lot more. And I think with blockchain technology and micropayments, specialization and smart contracts, we're going to see a lot more companies start to specialize, outsource, and engage with new types of value creation and division of labor, and invest in more resiliency. We're seeing this in supply chain with China starting to people starting to diversify out of China for their supply chain, right? In the manufacturer of electronics. But I think we're going to see that with software as well, and with more specialized services. So as somebody involved in making blockchain happen, I just wanted to offer my thoughts and commentary on the ways that blockchain might be able to help in resolving these types of issues. And of course, you're going to see outages, right? But I think those outages can be made a lot less severe. And I think that it's going to benefit people to have more resiliency and more specialization in various different markets, facilitated by micropayments, overlay services, and more resilient designs for the systems we rely on every single day.